Hi everyone, this is our live Skype session for Math 1046 and it is Tuesday, May the 9th. So it's very quiet in the session tonight. I don't have any participants except for myself and it's Lori here, but that's okay. These are not mandatory sessions, but I do like to record them. Normally it is it's a stop-in for you to ask your questions regarding the sections that we're working on through the week and to give you face-to-face time with me and to go over your questions. Now, I don't always have stuff to present, but I did have a couple of things that I wanted to show tonight based on the questions that I have received through email. And the first one I have is about absolute value. So absolute value is the last part of P.1. And in absolute value is where we have a number line, and the absolute value is the distance that a number is away from the 0 point on a number line. And the distance that number is away from the 0 is always going to be a positive number. So even if we have, let's say, -1, -2, and -3, and the question asks, what is the absolute value of -3? It's asking how far away from point 0 on a number line is -3. And the answer to that is that it is 3 units away from 0. And we always express absolute value as a positive number. Now, there was a little bit of confusion in the on the homework for P.1 because there was a concept check question where they said, okay, if you think of a number and you're asked to find the absolute value, how do you find the absolute value? And from what I said before, absolute value answers should be positive. Now, in order to get an absolute value, what you first have to look at is what is the number inside the absolute value markings. If that number is greater than 0, then your x is going to remain the same. Your number is going to remain the same. So in other words, if x is a positive number, then its sign is going to remain positive no matter what. Then there's another one that says, what happens if x is less than or equal to 0? What do we do then? It says then the answer is going to become -x. This causes a lot of confusion because if x is less than 0, it means that it's going to be in this negative realm, and this definition for what the absolute value of x becomes says that it's going to become negative. But this is where this is how you get through this confusion. Remember, if x is less than 0, then it's going to be a negative number. Therefore, when you are trying to find the absolute value of the negative number, you want to take the negative of that, which is a double negative. That's what this means. This means that if x is a negative number, then the answer is going to be the negative of that negative number. And we know that whenever you have a double negative, that's going to actually cancel out the negative and it becomes a positive. So when you see this definition for absolute value, when it's saying when x is greater than 0, when x is greater than 0, your absolute value is going to be x, positive x. And when x is less than 0, in other words, x is negative, you take the negative value of that to get your answer. Now, this is why this definition is important because sometimes absolute value isn't as obvious as what you might think. Let me show you some obvious ones first. If they ask us to find the absolute value of the number positive 5, we know that positive 5 is greater than 0. So our answer is going to also be positive, which is 5. We also know that if we have an absolute value of negative 3, to find the absolute value of negative 3, because negative 3 is less than 0, it's a negative number, we're going to put a negative sign in front of it. That makes it positive. So the absolute value of negative 3 is positive 3. Let's do another negative number. Let's do negative 105, the absolute value of negative 105. Again, the value is less than 0. It's a negative number. That means to find its absolute value, we are going to multiply that by a negative, negative 1, and that cancels out the negative values and we get 105. So the absolute value of negative 105 is positive 105. Looking at this, these are the obvious negative and positive cases for absolute value. You probably don't need to add that negative number in front to cancel out the negative sign, and that's okay. However, there are some things that aren't going to be so evident. For instance, if I asked you to find the absolute value of positive pi, we know that pi is equal to 3.15, repeating, or sorry, not repeating, but infinitely, continuing infinitely. It's greater than 0. Pi is greater than 0, so that means that the absolute value of pi is just going to be pi. Pi is 3.14 away from 0. But what happens if I said, let's take the absolute value of 2 minus pi? Is 2 minus pi a positive number or a negative number? To figure that out, what we need to do is say 2 subtract 3.14. And when we do that, we see that this is actually more of an approximate because we can't put all of the decimals on the pi. 3.14 just goes on forever. But 2 subtract 3.14 gives us negative 1.14. So what seemed to be positive inside the absolute value bars is actually a negative number. Therefore, when we want to know the exact value of 2 subtract pi, the absolute value of 2 subtract pi, what we need to do is first recognize that this is actually less than 0. Therefore, our answer is going to be the negative value of 2 subtract pi. Now you can see we're adding this negative in front of our value is going to give us the exact absolute value. That negative number then has to be applied to everything inside the brackets because this alone here is not simplified. We need to get rid of the brackets. So I'm going to use the distributive property and apply the negative to everything inside the brackets. So I'm going to get negative 2, and then negative times negative pi is positive pi. So the answer to the question, what is the absolute value of 2 minus pi, is actually negative 2 plus pi, because the value inside the absolute value bars here is less than 0. And when you have a value that's less than 0 that you want to find the absolute value for, you have to add the negative sign in front of it. I'll give you another example. This one doesn't include pi. This one includes the square root of 3, so a radical, subtract 1. What is the absolute value? First thing that we need to do is we need to decide whether this is a number that is larger than 0 or less than 0. In other words, are we dealing with a negative number or a positive number? So I'm going to first find the approximate value of the square root of 3. So on my calculator, the square root of 3 is approximately 1.732. And I'm going to subtract 1 from that. And I get that that's approximately equal to, so this is my approximately equal to 0.732 approximately. What this tells me is my value inside the absolute value bars is greater than 0. So that means that I can keep my answer inside as positive. So the absolute value of square root of 3 subtract 1, the absolute value of that is just going to be square root of 3 subtract 1. I didn't have to put a negative in front of that expression because it is equal to a number that's positive or greater than 0. Okay, let me see if I can find, I think I had one more based on that. Let's see. Just looking back in my notes here. There we go. Here's another one. What about if I gave you the absolute value of, oh, I see Morgan's in here. Hey Morgan, I'm talking to myself. Let me know if you can hear me. You can grab the chat window below, or you can just turn on your mic and let me know that you can hear me, okay? I wish it would ping when someone came into the session. Otherwise, I don't recognize when someone's in. Oh, hey Morgan.
Did you get my message?
Yes, I did. Thank you. Hi.
Hi.
You can hear me. Sorry about that. I waited for a little bit, and then when nobody came in, I thought, well, I'll just go over a few things, and then if someone comes in, I'll stop. How are you?
Good, how are you?
I'm good. I'm good. How's it going in the unit so far?
Good. I just was doing some practice today, and I was getting it, so I'm hoping
Nice.
it catches on a little bit more.
Oh, well,
a bit quicker.
That's good. That's good. Have you gotten to the part in P.2 about absolute value? That's what I was just talking about tonight, right? Before you came in.
No, I'm still on 1.
Okay, perfect. Well, this is the end of P.1. This is like outcome number 9 in the section. So as you get past interval notation and unions and intersections of sets, you're going to finish with this absolute value stuff.
Okay.
Okay. So I was just, how far did you come into this? Did you come in, like, did you see the part where I wrote about the the number line?
Like, as soon as I came in, you said hi to me. So that was it.
That was that quick.
Yeah, my computer's really slow, so I was just trying to get on it. So.
Okay. Well, I'm glad you got on. If you find that it's not working that well, I have it recording, so you don't have to worry if something happens and it doesn't come through. I'm recording it tonight.
Okay.
Okay. So I'm just going to finish what I just started here, and then did you have questions for me tonight, or were you just popping in to see what was going on?
I was just popping in to see what was going on.
Cool. Okay. Well, if I can hold you for one moment, I'm going to finish my thought here, and then we can chat a little bit more, and you can also ask me questions about this too. But this is just when you get to the end of P.1, they talk about absolute value. Absolute value is shown by a number with these 2 lines on either side, and all it means is how far away a number is from the 0 point on a number line. So -3, for instance, is 3 units away from 0. So when we say, what is the absolute value of -3? It's +3.
Oh, okay.
Morgan, can I get you to turn off your microphone?
Yep.
for now. But then when you want to talk, just turn it back on. I think I know you can. I think that the fan in your microphone, it sounds like a helicopter on this side. Mine does that every once in a while too. But as soon as you have a question, you just grab your microphone and turn it back on. Okay, again. Okay.
Okay.
Okay. Perfect. So the absolute value is just the distance a number is away from the 0 point on a number line. So even if a number is negative, like -3, its absolute value is going to be +3 because we just want to know the distance, and it doesn't matter whether it's on the negative side of the number line or the positive side. So when we talk about the rules of absolute value at the end of the textbook and in the homework in my math lab for P.1, there's a concept question where they say, I think it's like true or false, if you have the absolute value of x and x, in other words, any number inside the absolute value bars, if that number is greater than 0, in other words, a positive number, your answer is going to be the positive number. If x is, right here, less than 0, in other words, it's a negative number, then you are going to get the negative value of that negative number, which looks like this. So the negative value of that number, well, we already said that that number is going to be negative, so a double negative gives you a positive number. So absolute values of just an integer, in other words, a positive or a negative number, is always going to give you a positive based on these rules. There was some question around this right here in that because it looked like they were saying if x is going to be positive, you're going to get positive x, and if x is going to be negative, you're going to get negative x, which doesn't make sense for an absolute value because you can't have negative numbers. But what that really meant is a double negative, because you already know that your value is negative, and so to get your absolute value, you do the double negative, the negatives cancel out, and you get a positive number. Now, when we do this on a number line, we automatically do this in our head. We don't put negative, negative, and think positive. We can just see that on a number line that when we talk about the distance away from 0, we don't worry whether it's positive or negative. We just count the units. But where it becomes important is when you get an expression like this. And this was the last one that I wanted to put up. And, oh, I lost it. Just a sec. It is... Dun, dun, dun. Here we go. So we have the absolute value of the square root of 2, subtract 5. So the square root of 2 subtract 5, just by looking at that, it's hard to see whether we have a positive or a negative number. So what we have to do is we have to find the approximate value of the square root of 2 subtract 5. And when we do approximate value, we use this wavy equal sign to say approximate. And then what I'm going to do is put the square root of 2 in my calculator, so 2, and then I'm going to press the square root button. That gives me approximately 1.414 and a bunch of different decimals, but I'm just going to do that amount. Subtract 5. And then I'm going to simplify inside of the absolute value lines, and 1.415 minus 5 gives me negative 3.58. So that's the approximate value of square root of 2 minus 5 inside the absolute value bars. And because I have a negative inside, that means that my answer to get rid of the absolute value bars is going to be the negative of negative 3.58. And you can see that my negatives cancel out and I'll get positive 3.58. But that is just an approximate value. What they want us to find is the actual value. And the actual value won't be in decimals. But the reason why we had to do the approximate value is I need to know, am I dealing with a number that's greater than 0 or less than 0? And in this case, I can see that the square root of 2 minus 5 is less than 0. And when I have a value of x that's less than 0, then my answer is going to be the negative of that value. So how that translates to this expression of the square root of 2 minus 5, that's going to be negative, because it's less than 0, the square root of 2 minus, oh, that's supposed to be parentheses, 5. So I have to apply this negative to everything inside the parentheses. So I'll get negative square root of 2, and then that other negative, negative 5, that's going to make that positive 5. So my answer, the exact answer to the absolute value of square root of 2 minus 5 is going to be negative square root 2 plus 5. So when we look at the absolute value questions, I think it's those questions where we're finding the absolute value of an expression that students can sometimes have problems knowing whether you're dealing with, whether you need to take the positive value of that expression or apply a negative to it, and it all depends on whether the expression is greater than 0 or less than 0. Morgan, do you have any questions about that?
I don't really have any questions right now. Maybe when I get to that, like when I'm going through it myself.
Yes, yeah, I know. I'm giving you, it's like, because you haven't seen it, so that's great. And you'll have this recording, so when you get there and you go, oh, I see, I'm confused, you can come back and look at this.
Yeah.
Yeah, cool. Okay. So the other thing that I was going to talk about was just the difference between interval notation and set builder notation. So have you done some of those already? Those are the ones where, let's see, I have one here. That's something like if you have, oh, here we go. Let's say you have, now this is in interval notation where you just have the round brackets and the square brackets. So you might have a question like this. In the set of positive 1 to positive 4 and the set of 2 to 8, find the intersection point. So this sign here means intersection. Have you gotten that far yet, Morgan?
Yeah, I was just doing some of those earlier. So I was finding I think I was finding the intersection of the two sets.
Yeah. Perfect. So that's what I just wanted to say about these. Whoops, and should be a square bracket, is when you're doing these, you really have to look out for the round brackets and the square brackets and know that the round brackets means that you don't include the numbers, and the square brackets mean that the numbers are included in the set. So in this question here where it says find the intersection of these two sets, what you want to do is to draw the number line for this. So for the first set, we're looking at a set of all numbers inside 1 to 4, but not including. So we're looking at, it doesn't matter how you draw your number line, but let's say this is 1, 2, 3, 4. So this first set here is going to be between 1 and 4, and I like to put the round brackets to show, and this is the interval notation. So everything inside of here is going to be that first set, and then the second set between 2 and 8, where 2 and 8 are inclusive, that's going to be here for 2, and then 5, 6, 7, 8, a square bracket for that. And then I'm going to highlight that in a different color. So I'm looking at 2 to 8. So the intersection point is going to be here and here, where both sets overlap each other. So when you write the answer, what is the intersection of these, you look to see what your limits are. And I can see that my limit is going to be 2 and 4. And then to finish off my interval notation, I look and I see that I have a square bracket on the 2, so that means I'm going to include the 2 in this intersection set, but the bracket on 4 is a round bracket, so that tells me that my answer is going to have a round bracket around the 4. So that's the answer to the question, what is the intersection between the set of 1 to 4 and 2 to 8? This is your answer in interval notation, and then set builder notation is when you have to give it as a set where X is a member. So whenever you do set builder notation, you're always going to do a squiggly bracket first, and then the X, and then a line. And what this first part of set builder notation means is that X is a member of. This line means member of. And then you're going to write the set as an inequality. So you're going to say that X is going to be greater than and equal to 2. And that equal sign is there because we said that 2 is included in the set. And it's going to be less than 4. But you can see that I don't do an equal sign because 4 is not included in the set, showing right here. And then you just finish set builder notation with a squiggly line. So for P.1, it's important to be able to express your answers in interval notation, which is just the square bracket or the round bracket, but also in set builder notation where you're saying X is a member of an expression that has inequalities in it. Morgan, how does that sound?
Yeah, that sounds like
all good so far, right?
Simple was easy, so yeah.
Yeah. I think the big thing for this part is whether just making sure that when you draw out the number line, that you use the correct parentheses, like a round parentheses where it's needed in square parentheses, and that will translate better into your answer.
Yeah.
Okay. Yeah, so that's between absolute value, using interval notation and set builder notation, and understanding intersections and intervals, and being able to identify your real numbers, your natural numbers, whole numbers. That's pretty much P.1. P.2, which you haven't gotten to yet, that's mostly to do with simplifying algebra expressions. So we did a lot of that already in the refresher unit, or there was practice in the refresher unit. So P.2 should be just a little bit more practice just to refine everyone's algebra skills. Did you want me to show you some of the, just some examples of what you're going to see?
Sure.
Okay. So I'm just going to pick, I have one here. So sometimes it's simplifying a big long expression, like this one's a good one. Let me grab my pen. So this is one type of question that you might have. And it will say simplify this algebraic expression. And the reason why we know to simplify it is because there isn't an equal sign. And by simplifying, they want us to get rid of any brackets or parentheses, and they want us to combine like terms. So the first thing we're going to do is get rid of the parentheses. And over on this side here, the easiest way to get rid of the parentheses is to apply the sign in front to everything inside the parentheses. Whenever you apply what's outside the parentheses to everything inside the parentheses, that's called the distributive property. So we're just distributing this negative sign to everything inside the parentheses. And to do that, I just multiply everything inside by -1. So -1 times 5x is going to give me -5x, and -1 times -11, whenever you multiply two negatives together, you get positive. So that negative sign basically changed the signs inside of this expression. So I get -5x plus 11. So that's simplified. I got rid of the parentheses. And then for the first part of this equation here, using the distributive property again, I'm going to take +3 and apply that to everything inside of the parentheses. So 3 times +x gives me 3x. 3 times -7 gives me -21. So my first step here was just to get rid of the parentheses by using the distributive property and taking what's in front of the parentheses and applying it to everything inside. Morgan, are you okay up to that point?
Yes.
Perfect. Okay. So my next thing, my last step, is to combine like terms where I can. So I'm looking at this expression and I'm going to look for terms that have the same variable, and I see that I have x as my term. So that means I can take +3x and subtract 5x. So +3x subtract 5x is going to give me -2x. And then -21 and +11, those are like terms. So -21 plus 11 gives me -10. And that's simplified. So that's as far as I need to go with that one. My parentheses have gone. My like terms are combined. There aren't any fractions that I need to reduce. So that's that expression simplified. Morgan, how do you feel with those types of questions? Did you have any questions about that?
No, I practiced those a little when I was doing the refresher test.
Okay.
So I think I'm okay with those ones.
Oh, pardon me?
I think I'm okay with those ones.
Okay, perfect, perfect. Okay, so the other thing that you might see is more on the formula side of things. So for instance, another example is where we have perimeter is equal to 2 times the length plus 2 times the width, and they're saying solve or rearrange this solution to solve for W. So you might remember those from the refresher unit, so we have a little bit more practice on these. So in algebra, when you rearrange expressions to solve for a variable, what you want to do is you want to isolate the variable you're trying to solve for. So what I like to do is get W by itself. And in order to get W by itself, you need to bring everything else that's with W over to the other side. So we want to bring 2 times the length and this 2 here over with P. And you always work with the things that are the furthest away from the W. So I'm going to bring this 2 times the length over to the other side and leave whatever's closest to W till the end. So looking at 2 times the length, we're actually adding 2 times the length because the sign in front of 2 is actually a positive. So if we want to move that to the other side, we're going to do the opposite of adding 2 times the length. So that's going to be subtracting 2L. And whatever we do on one side, we're also going to do on the other. So when I subtract 2L from this side, it actually cancels out. That's going to leave me with 2W. And on this side, I'll get P subtract 2L. And I can't combine those P subtract 2L because the P and L are not like terms, so I just have to leave it as is. And then I'm left with P minus 2L is equal to 2W. So to get W by itself, I need to bring the 2 over to the other side. And to do that, I say, okay, what's 2 doing to W? It's multiplying. The opposite of multiplying is dividing. And whenever you do the opposite operation, it cancels each other out. And whatever you do to one side, you also have to do to the other. So that gives me that W is equal to P, the perimeter, subtract 2 times the length divided by 2 is going to give me what W is equal to. So P.2 is really about simplifying algebraic expressions. It's about rearranging formula to solve for a variable inside of the formula, and it's just really emphasizing just the rules of algebra. A lot of people like P.2 because it's a nice recap of their algebra rules, and there's lots of practice with that. And that's really what I wanted to go over tonight, was just P.1 and P.2. The other part of the unit is P.3 and P.4, but I'm going to leave that because I know that most students are working through P.1 and P.2 still this week. And then on Thursday, I'm going to post the review videos for P.3 and P.4 so that next Tuesday we can go over questions from P.3 and P.4. How does that sound, Morgan?
That sounds great.
Okay, great. I don't really have anything more to show tonight regarding P.1, P.2, unless you have some questions for me.
No, I don't have anything right now.
Okay, no, that's great. Thank you for coming out tonight.
Okay, thanks.
Do you have any questions about just the course in general? Are you having any problems with my math lab or just navigating in D2L?
I think I'm getting the hang of it slowly, but
Good.
it's tough.
Oh yeah, no, I say it takes probably, like we're just into the week 3 now, and I think that usually by week 4 students are starting to feel more comfortable because they've had enough time to go through and stuff. We're only on unit 1, so I'm not expecting anybody to be super comfortable yet, but it will come, I promise.
Yeah, I have a friend at work that recently took it, and he's like, if you have any questions, let me know, because I know it can be a little bit confusing.
Oh, that's fantastic. No, that's great. And also, you know, you can reach out to me anytime. I know students are a little bit nervous about doing that, but that's why I'm the human in the course.
Yeah.
I'm here to help, so feel free to email me or text me or phone, whatever, you know, you feel most comfortable doing. And it's so great that you have a friend that's gone through it before. A little bit of moral support.
Yeah, exactly.
Yeah. Well, that I'm going to stay in until 8:30 just in case there's anybody that's just popping in, but otherwise, good luck this week with this.
Okay, thank you so much.
No problem.
All right, bye.
Bye.